Doot, 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 doot. Doot, 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 doot. All right. All right, everyone. I want to go ahead and start class. I have your quiz from last time that you turned in. I'll give those back to you maybe when we do our break. I want to talk about the final exam. A lot of people have been asking me about the final. Here's the plan on the final right now. The final will only cover things like implicit differentiation, related, I know you're going to get mad, rates, and then pretty much chapter 4 and possibly 5.1, depending on how far we go. Now, chapter 4, that's a big deal. I mean, that's everything we've been doing since the test, right? Well, yeah. You know, the max-min stuff and all that, it's curve sketching, word problems. But people want to know, is it comprehensive? How far back are we going? Well, I'm not going to test you on every little aspect of the class that we've gone through. Those are the major topics. So the only thing really from the past are these two. Now, that's kind of like option 1. Option 2 for the final is for someone who really is trying to bump their score up. Okay, so maybe you're in a situation where I told you, look, you need 100 for a B. Like, you can pass the class, but you need 100 for a B. So you're like, okay, I can't get a B. Well, I'm willing to offer more points to you if you want to take option 2 for the final. And option 2 would be comprehensive, okay? I'm just going to say it would be comprehensive, and all I'm going to tell you on that is to go study the other exams. Go study exam 1, go study exam 2, and the same things that I put on there above, right? Those same things are going to be on that comprehensive also. So it's going to be a longer test and a harder test, but it can up your score on one of your old tests. Like maybe you got a 40 on a test, you take option 2, and I'm not going to say I'll replace that score, but it will come up, all right, if you do better. It's like a bonus, yeah. Now, you have to choose, okay? The day you come in and take the final, you have to choose which one do you want. If you're happy with your grade, just take the first one, get it over with, get out of here, you're done, right? You take option 2, well, bring a sleeping bag. No. It won't take that long. But it'll be long, you know. It'll be the full, what, how long are we here? 3.5 hours or something like that? It'll probably be the full 3.5 hours. Yeah. I don't know. I haven't made it yet. Yeah. Okay. We can talk more about that later. Monday, we can talk more about the final. I'll try this weekend to put something out on the web as a review for the final. The only thing I'm going to really put a review out for is option 1. Again, option 2, I'm just going to say go study your old tests. And the solutions to exam 1 and exam 2 are now on the web. Okay, if you go to our Canvas and you click on Files and go to Solutions, they're there. And I also put on there just today, you know where all our class videos are? Some of you do, some of you, I don't know if you've ever gone there, but if you go to where I've been recording these videos, under Solutions, under the videos, I just put problems 11 and number 11 and number 22 from 4.4. That's the sketching, those curve sketching problems. Number 11 and number 22 I did. It took me like 45 minutes to do both problems on video. And then in Canvas, under Files, under Solutions, I put the PDF of everything I wrote for that video. Because I think those problems are so important, you're going to see it on the test, I wanted to give you 2 more examples that you could go back and look at. Okay? All right, the rest of what we're going to do today is finish Chapter 4. I will entertain any questions you have over homework or over anything related to this class. Anyone have anything for me? You ready to go? All right, so the curve sketching is where we ended up last time, right? I've only shown you 1 curve sketching problem. That's it, in class. You now have the other 2 I put out there for you, so now you have 3 to go off of. They're all a little bit different. I mean, there's little subtleties within each problem that make them different. You know, the way that you find the x-intercepts, the domain issues. So the only way to get good with those is to practice them. I'm going to avoid on the test giving you anything like ridiculous, because some of the problems in here get really challenging. So, you know, stick with the ones kind of in the teens, like 1 through like 28, something like that. How'd your thing go? It's good? All right. So I don't intend on covering anything else in 4.4 today. I'm ready to move on to 4.5. So for 4.5, I'd like to start with 2 basic ideas we have here. Okay, they're very different. Finding max-min on a closed interval and finding local max, local min on implied domain. Let's talk about the differences between these 2. If I was on the left side here, finding the max-min on a closed interval, I'd be looking at a function, right, that started at some point, ended at some point, and I'd be trying to locate the highest and the absolute lowest, right? Those 2 points would represent the max and min. What is the technique used to do that? What kind of give me, if you can think it, if you know it in your head. So you do the derivative, set it to 0, figure out where it's undefined, right? So find the critical numbers, right? What do you do with those critical numbers? Plug them into the original function, and then what else do you plug into what? Endpoints into the original function, right? So, I mean, if we're just trying to like real rough sketch of how you do this, you make sure it's continuous, right? You make sure it's on a closed interval. You find the critical numbers. Then you look at the endpoints. You take those critical numbers endpoints, plug into the function f, right? That's the basic idea. But we have to have a continuous function on a closed interval to do that. What we did in the last section, in the curve sketching and the one before it, is we said, well, what if we have a function and we don't have a closed interval? Our function is defined on whatever its domain is, and we want to go and try and find max, local max and local mins, right? The process for doing that is very different. What do we do here? I'm talking just local max and min. If I ask you to find local max, local min, not sketching it, not all that, concave up, concave down. Just if I ask you to find local max and mins of this, how would you do it? Okay, so you do derivative, set to 0, figure out where it's undefined. So we'd still be finding the critical numbers, right? Right? We'd still do critical numbers. But then what? Number line, right? Then we do number line with critical numbers. Then test points. Where do we plug those test points into? Into the derivative, right? What does that tell us? Positive means up and increasing, negative means decreasing, right? So there we're able to make that like table that shows arrows going up and down, up and down. And then what we're looking for is where it goes up, down is a max, and where it goes down, up is a min, right? So I'm just going to show under this like up, down, up, something like that. We make number line. Is that enough for you to just look at it and kind of know what I'm talking about there? We also had to be careful, right, with that. Whenever we had the switch, like it goes from up to down, what did we have to make sure about that point right there at the bottom there? What do we have to, before we could say that was a local max or something, we'd have to make sure what? Is what? That, yet the function exists there, that point's in the domain, right? You cannot have a local maximum at an asymptote. So we have to be careful. So do you see, though, that there are two very distinct and different approaches to trying to find maxes and mins on closed intervals versus maxes and mins on an implied domain? Yes? Okay, the section we're going to do now are word problems. And every word problem we look at is going to fall into one of these two categories. It's either going to be trying to find the max and min on a closed interval or find the max and min in the entire domain. Okay? Depending on which one it is, that will dictate which method we use. All right? It's going to be in the problem somewhere. No, it's not always going to be clearly, an obvious thing. Okay? But if we notice it, then it makes the problem a lot easier. Because wouldn't you agree that the closed interval method is easier? I mean, it's just critical numbers, plug in, done, compare, we're, next. So, all right.
Why can't you just plug in for the applied domain? You just
For,
put those numbers into the function, but still know which ones are higher than the others.
yes, that's true. You'll know which ones are higher, but you could have you could have a lot of different local maxes and mins, right? Like, let me just show you a picture real quick. And so, like, let's say I had this. So to get this, you would have to actually compare. There would be a lot of different comparisons, right? And you have, the highest one would be at the end. I did that intentionally. So I guess answering your question is that just because 2 points, one is higher than the other, if there's a lot of them, then you have to compare each one. I don't know if that...
So one's going to have to figure out if it's increasing or decreasing with all of them.
You would have to do that also, yeah. There would be no way around it. Let me think more about this. Let me think while I'm writing out the note. That's a good question. Continuity clip. I'm going to think while I'm writing. On the notes for 4.51, we have a set of steps. Does everyone have the notes printed out? Yes, for chapter 4? I'm looking at 4.51. It's going to be 6 steps.